Hello friends, welcome to Sidza.com. Now we will discuss about the chemical kinetics. In a chemical reaction, like suppose A plus B, it produces the C. When we write down the reaction, we normally say the reactants get converted into the product, and we mention the reactants and the products, right? In a chemical reaction, what are the reactants which combine and what are the products that you get. But in addition to this, think the nature of the reactants and the products. As chemists, we are concerned with other topics as well. For example, we want to know whether a particular reaction can occur or not, right? That means we want to know whether the particular reaction is feasible or not. Can the reactant A combine with the B? And can this reaction occur under the given set of conditions or not? This thing and other related topics we get from the thermodynamics, right? So this is something that is concerned with the thermodynamics, right? So thermodynamics will tell us whether the reaction can occur under the given set of conditions or not, whether the reaction is feasible or not, whether A will react with the B or not. Similarly, we are also concerned about the extent of a reaction, right? Up to what extent the reaction can occur, whether the reaction is reversible or irreversible, right? And this is the topic which is related with chemical equilibrium. So chemical equilibrium will guide us here up to what extent the reaction can occur. Similarly, we are also concerned about the speed of a reaction, right? How fast the reaction can occur, how fast the reactants get converted into product. And this is the topic of the chemical kinetics, and this is what we are going to study in the chemical kinetics. So in chemical kinetics, we'll study about the rates of the reactions, right? That means we will study what is the time taken by the reactants to get converted into the products. So change in the concentration with the time, this is what we will study in chemical kinetics. So the main topics of this chemical kinetics are: number one, we'll discuss how to write down a rate of a reaction and what does actually the rate of a reaction mean. Second thing, what is average rate and instantaneous rate? How are these two things different? Third, what is the rate law, order of a reaction, rate constant, and factors which affect the rate of a reaction. We'll also discuss about the integrated rate laws of the zero order, first order, and second order reactions. We'll study about the molecularity and the order of a reaction, right? We'll study what the molecularity means and what the order of a reaction means. We'll also discuss about the collision theory and activation energy of the reaction, right? We'll also discuss about the Arrhenius equation and activation energy. So all these things we will cover here in the chemical kinetics. Broadly, we classify the chemical reactions based on their rate of reaction, based on the speed, right? Speed of the reaction, how quickly reactants get converted into product. So we can classify the rates, we can classify the reactions based on the rates into three main categories. Number one is some of the reactions are very, very fast, quick, right? They occur in a fraction of a second. And some are very slow, right? It's very difficult to, it's very difficult to study these reactions. Very, very slow, okay? Take a lot of time. And some of the reactions, they are moderate, okay? They are not so quick or they are not so slow. So let's take here an example, right? An example of a very fast reaction. The reaction here is, if you write down, suppose NaCl, if you react the aqueous solution of sodium chloride with silver nitrate, AgNO3, right? What do you get? We get actually the silver chloride, which is actually a white PPT. So you get a white precipitation of a silver chloride, and you also get sodium nitrate, right? We also get a NaNO3. Sodium nitrate. the white precipitation will be quickly formed. As soon as you mix the sodium chloride solution with the silver nitrate solution here, you get a white precipitation. The reaction is very fast, right? Quite fast. Now let's see here one particular video on it. Let's have a look at this experiment. Here I'm going to make NaCl solution, sodium chloride solution. This is the distilled water, and when I add some NaCl in it, you got the aqueous solution of sodium chloride, NaCl. And when you react this particular solution, right, we got a clear solution of NaCl, and when I mix it with the silver nitrate, here is the silver nitrate solution. This is HgNO3. Okay, you will see as soon as I mix the two, okay, when I add silver nitrate solution in NaCl, you will see a white precipitation very quickly formed here in this reaction mixture. This is silver nitrate, HgNO3. As soon as it touches it, right, you can see here, as soon as it touches it, and you got the white precipitation, right? So this is a very fast reaction. Okay, some of the reactions are very slow. Like suppose if you react the hydrogen with oxygen at room temperature, the reaction is quite slow, right? At room temperature here, the reaction is very slow. It forms the water here. Okay, you get 2 molecules of water, twice hydrogen, right? So now this is the balanced equation, and basically this reaction is very slow reaction. And in moderate reactions, these reactions they are not so extremely slow, they are not extremely fast, right? They occur at a moderate speed. One such example is the this inversion of a cane sugar, or you can see the hydrolysis of the sugar. When we hydrolyze, when we break down this molecule, the cane sugar, into 2 units of the C6H12, one is glucose, the other one is fructose. So hydrolysis, or you can see the inversion of the sugar here, right? Inversion of the cane sugar in the aqueous solution. This is a moderate reaction. Hope you got the concept. Thanks for watching the video. Bye for now.